All right, we're doing our notes for section 2.1, solving equations. A lot of this should be review. You should know how to solve equations at this point, but we haven't just done straight equations for a while, so let's review on those. So when you're solving any kind of equation, no matter how simple or complicated, you're always just trying to undo what's been done to get back to the variable by itself equals an amount. You're trying to find that unknown amount, okay? So Mr. Sanders had a balance of $405.87 in her account. Miss Sanders. She deposited D dollars and her new balance was $552.25. So she had $405.87. She added some amount of dollars and she ended up with $552.25. How do I solve for that? How do I solve for that? There we go.
Is this really our first question?
It's review.
We have to go over it. I mean, like, I thought it was going to be like really hard. I'm so sorry.
I think it's awesome that you think that this is so easy, so let's roll with that. That's good. So 147.38. I don't like to assume anything, Jaden. Okay, next one. The temperature was 54 degrees Fahrenheit. Part of it is being able to read those word problems too and know what you actually need to do to solve the equation. Equations are easy when you're just given equations already written out, but when you have to come up with your own equation from a word problem, that seems to be problematic for some. So the temperature was 54 degrees Fahrenheit. The temperature dropped D degrees. The new temperature was 35. So did we add or subtract those degrees?
Subtract.
Anthony is not thrilled with these, but that's okay.
This isn't pre-algebra.
This is
like 2 plus X.
You guys, let's just enjoy it while we can.
This is what I'm saying. I love that this is being recorded.
I know.
Third and fifth period will find it highly entertaining. It's okay. Okay, pizza's here. Domino's Man has brought 8 pizzas for Mr. Rum's class to share. There's 72 pieces, 72 slices of pizza total, and 24 students in her class. How many does each student get? Are you going to figure that out? There's 72 pieces total, which is kind of odd because that means that there's 9 pieces per pizza, and there's never an odd amount of pizza number of slices on a pizza, but that's okay. Unless what? Why are you using that word? Because now I have you on voice and you sound really stupid using that word, so don't do that again. So each person gets 3 slices. But thanks, Arcadia. Okay. Miss Sanders has parent-teacher conferences with 1/4 of her students. She has 30 conferences. How many students does she have? Jaden? I thought you didn't need me, Jaden. Okay. How did you figure that out? Don't be shy now, children. Come on, I thought these were easy. Nick?
Multiply 30 by 4.
That's one way. Since 30 is the 4th, you could do 30 times 4 gives you the number of students, or 30 is, and equals, is the equivalent of is in a word problem, is 1/4 of something, of some amount. S or X or whatever letter you want to use is really kind of irrelevant.
Pretty easy.
Can we not use SY?
I completely forgot. It looks like a phone.
Wow. You guys are going to so love this later when you hear yourselves on. Okay, so let's work on the 3 below. And I'm going to hit pause. You're going to work on the 3 problems below, and then we'll come back together and check your answers. So you have 3 minutes to do those 3 problems. All right, so for the first one, need to undo parentheses, subtraction, and multiplication. So you would have negative 18 minus 6k. Use your distributor for property to have 6 plus 18k. I always move things. I do variables on one side, numbers on the other side. I do it in one step now. You can choose to do that or not do that. So you get negative 24 equals 24k. So k equals negative 1. Plug it back in to check. Negative 18, negative 6 times negative 1 would be 6. And that should equal 6 times 1 plus 3 times negative 1 is negative 3, which would be negative 2, so that'd be negative 12, and negative 12, so that checks out. Second one, you gotta do a whole lot of distributive property before you do anything else. So you have negative 12x minus 9 plus 24x plus 4 equals 43. I'm gonna combine my x's on this side and have 12x. Negative 9 plus 4 is negative 5, so I'm going to add 5 to this side, and I'll have 12x equals 48, so x equals 4. If I go back and plug that in, 4 times 4 is 16, plus 3 is 19, plus 6 times 4 is 24, plus 1 is 25. That should equal 43. 3 times negative 19 is negative 57 plus 100, which does equal 43, so that one checks out. Okay, so before you start flipping out with fractions, what's the easiest way to eliminate those fractions?
Bust them.
Bust them. How do you bust them? Multiply by what? Take your denominators and multiply them together. That's all you have to do. I don't care about lowest common denominator, it doesn't matter. The easiest denominator to come up with is multiply your denominators together. That by default makes them the common denominator. Doesn't matter if it's least or not because you can always simplify it out. Okay? So then multiply each of those things by 12. And then you'll have no fractions anymore. So you have 12m. 2 times 12 is 24, divided by 3 is 8. Or the other way you can do that is 3 goes into 12 4 times. Multiplied by 2 is 8. A fourth of 12 is 3. And negative 1 times 12 is negative 12. Variables on one side, numbers on the other side. So 9m equals negative 20. So m equals negative 20 over 9. So checking that might become a little bit more problematic, but not really. I'm going to do it down here so I've got a little bit more room. So negative 20 over 9 plus 2/3 equals 1/4 times negative 20 over 9 minus 1. So eventually I'm going to get rid of all these fractions, but let's multiply this out first. So you have negative 20, actually I'm going to, no, we're fine. Negative 20 over 9 plus 2/3 equals negative 20 over 36. And I'm going to change this to a 36 to make that easier. That'd be negative 36 over 36. So on the right-hand side, I have negative 56 over 36. If I'm just checking to see that the two sides are the same, I would want to change both of these to 36 also, just to double check that they really are equivalent. So in order to do that here, I would need to multiply both by 4. That would give me negative 80 over 36. And here I would need to multiply both by 12, because that would give me 36. So that would give me 24 over 36. Since all of my denominators are the same, I just need to verify that my numerators add up, and negative 80 plus 24 is negative 56, so that checks. So yes, you can check it even when there's fractions, even when they annoy you, but you can. Here we got it?
Yeah.
Jaden, are you glad it's not so easy anymore? Oh, now she's afraid to speak. I love that.
I need the volume chart. Thank you.
I should play the Jeopardy music while we're doing
Okay, we're good.
it. Okay. Is everybody good?
Hurry up.
Going in 10. All right, just a few more word problems, and then we'll move on with that. The ice cream truck comes to your neighborhood. Used to love that as a kid. Some kids bought Bomb Pops, which cost $1.10 each. The same number of kids bought strawberry shortcakes for $1.50 each. Altogether, they spent $15.60. How many kids bought ice cream?
Like,
Buy all of them.
A lot of ice cream.
It is a lot of ice cream. So it's the same number of kids buying both, right? So what can you use as your variable?
2.
That was Michaela. Thanks, Michaela. What variable would we like to use? X. Because we know it's the same number of kids, right? So we could use K, we can use X. Forever enshrined there, Michaela. Okay, so some kids bought $1.50 worth, and the same amount of kids, so our X is the same value, paid $1.10 for theirs, and they spent $15.60 altogether. How many solve that out?
add the 1.5 plus the. Subtract 1. Oh, wait, yeah, subtract 1.
No, because they're both X's.
Combine like terms. Combine like terms.
Oh, wait, combine like terms.
Combine your X's.
Class, how did we pass geometry? I like passing. I like passing geometry. I suck at algebra. If I reach it, wait, why is it 1520?
I'm going to do 1560. So how many kids were there? 6. Now think about that logically, if we can. I don't know, we just said a variable was 2, so maybe we can do it logically. So there were 6 kids. It's not 2. It's not a variable and it's not our answer, yes. What?
That's like over $2. I have a question. No, it's not.
$1.10 is expensive for ice cream? But you guys would go to Cold Stone and spend like $7 on a milkshake. Okay, good. Marie? So, okay, so I didn't, but I know I can't have half a kid, right? So think about it this way. If you know that that's in the end of that, Channing?
Oh, they spilled water.
I spilled water.
Fabulous.
But
Okay, think about your multiples of 6. So like if I do 6 times 5, that's going to give me 50 cents, sorry, 60 cents times 5 is going to give me $3 even, right? So that's not enough. If I had 5 kids times 260, I'm in about, what, $12, $13, somewhere in there, right? But I need to get up to 15. Well, if I have 7 kids at 260, now I'm up to $14 plus another 4 something, so I knew that was too many. So even if I'm estimating, you can divide that out with a calculator, I'm fine with that too. But I know it's got to be in between 5 and 7, because 5's too little, 7's too much. Charlize?
I think like what Marie was asking is like, how do you know that 4 kids didn't buy the 110 and then 2 kids bought the...
Because it says the same number of kids bought strawberry shortcakes that bought, yeah. That's why we can use the same variable for both, because it's the same amount of kids. If it wasn't, then we would actually have to do a system of equations.
I know, don't mind.
Yep.
Isn't there like 12 kids?
This is how we should do
Wait,
all of them.
so there's 12 kids on. Tree went black, right? And then there's... I didn't know.
Okay, Jeff buys 2 lollipops on Monday, 2 on Tuesday, and 3 on Wednesday. He had 1 lollipop before I started. They have combined calorie count of 480. There's no question there. Let's make a question. What question could we answer? How many calories are in each? Okay.
There's no question on ours.
That's what I just said. Right. So we bought 2 on Monday, 2 on Tuesday, 3 on Wednesday, and he had 1 to start with. So how many did he have total?
8.
Getting better. And 8 lollipops had 480 calories total, so each lollipop had 60 calories. Wow.
That's a lot for a lollipop.
60 calories is not a lot.
Okay, Phil T. Rich has $100 and spends $3 per day. Quiet. Ernest Worker has only $20, but is adding to it at a rate of $5 per day. At what point will they have the same amount of money? Who will have more after 2 weeks? So, shh, Julia. In business, there's a term called break even. It's a really important term in business. What do you think that means? What do you think break even means? Corey, what do you think? Shh.
Well, the term is when you're basically spending the same amount of money as you're gaining.
Exactly. It's when your income and your expenses are exactly dead even. You're not making any money, you're not making any profit, but you're not losing any money. It's when they're exactly even. So if we're trying to figure out where they're earning the same amount of money, we're going to set their earnings equal to one another to figure out at what point are they earning exactly the same amount. So Phil has $100, but he's spending $3 a day. So he's losing $3 a day. Ernest has only 20, but he's adding $5 a day. So we need to figure out how many days are going to go by before they have exactly the same amount.
10.
Is that what it is?
I think so. Yeah, it's 10.
Are you guessing? Or did you figure it out? It is 10? Okay. I don't know. I haven't done it yet, so.
Yeah.
And it is. Okay, so after 10 days, they'll have the same amount of money, which will be how much? 70. They'll have $70 after 10 days. How did you get that? Sure. So if I'm plugging in 10 for D, 3 times 10 is 30, 100 minus 30 is 70, 5 times 10 is 50, plus 20 is 70. So after 10 days, they'll both have $70. Who will have more money after 2 weeks? What am I plugging in? Weeks. How many days are in a week?
7.
How many days are in 2 weeks?
14.
Where am I plugging that in?
D-W. No, it's 14 days.
Are they going to have the same amount after 2 weeks? No. The only time they're going to have the same amount of money is right at 10 days. After that point, they have differing amounts. Who do you think is going to have more money? Ernest will probably, yeah. So,
He earns
well, he's earning, period. The other guy is spending. So at some point, he's going to run out of money. The other guy's earning, so he's only increasing his amount. So that's 100 minus 52. No, 42. So Richard have $58, and then Ernest has 20 plus 70, so he'd have 90. So Ernest would definitely have more. Okay? Easy enough? Remember, be happy. Jaden, how do you feel about graphing and slope-intercept form? Would you like to know why I had to include this?
I don't what? I'm
Guys,
not.
it's one page.
People don't know how to count lines on graph.
Right, because I still have Algebra 2 kids who cannot do dot to dot and graph. So y'all are, no, I'm not kidding. I wish I were kidding.
I feel like looking at it, so like,
Okay,
But yeah, like that.
so we actually, so even though we are graphing in slope-intercept form, we're also going to do a little bit of graphing in standard form, just to make sure you have a handle on that, because when you are given standard form equations, if you know how to graph with your intercepts, it's so much faster than having to change everything to slope-intercept form. So what do x and y represent in any equation? What does x represent? Input. What does y represent? Output. Okay. What does that M represent? Slope, also known as what over what? Rise over run. It's how far you go up and down versus how far you go over. What does B represent?
Y-intercept.
Okay. Graphing in slope-intercept form is basically a dot to dot. Do not make it more complicated than that. Please, pretty please. Just graph your lines. So I'm going to give you several. Oh, can't do 6. So go ahead and get those equations written down and then graph those, please. And then we'll work on some standard form equations at the bottom. You always start on the y-intercept. So you start at -2, go up 3 over 1. Remember, anything with a slope over 1 is going to be pretty steep. Anything with a slope between 0 and 1 is going to be pretty flat. If it's positive slope, it's going uphill. If it's negative slope, it's going downhill. If you can remember those key things, you're fine. Going down 1, 2, 3, 4, 5 over 2. What kind of line is y equals 4? Horizontal. Go up to y equals 4. Line straight across. What kind of slope does a horizontal line have? 0. Slope equals 0. What kind of line is x equals -2?
Vertical.
Vertical. What kind of slope does it have?
Undefined.
Undefined. Good. So you go to -2 on the x-axis, vertical line. Okay, 7x minus 4. So somebody said to me, do I just draw it off the graph? Well, can't that line go both directions? So you can go up 7, 1, 2, 3, 4, 5, 6, 7, and over 1. And then starting at 4, same thing with this. You can't go up and over, so you can go down and to the left, which is a negative over a negative. So go down 1, 2, 3, and over 1, 2, 3, 4. Easy enough. Okay, let's do some standard form equations. Let's do and okay, the easiest way to solve these, what do you know about any x-intercept? What's its y-coordinate? If it's sitting on the x-axis, what's its y-coordinate always going to be? 0. You always know that for x-intercepts. For y-intercepts, they're always on the y-axis, and their x-coordinate is always 0. The way I think is easiest is to split these up and set them each equal to the constant and solve. It's way easier. So x, because you know that that other point is going to get eliminated just for the fact that it's sitting on, at some point that line has to cross both the x-axis and the y-axis. So your x-intercept would be 5, and your y-intercept would be 3. And there's that line. Even when they don't come out evenly, it's still the easier way to graph. When they don't come out evenly, like when we're doing systems, you want them to be pretty accurate. So you, in that case, you would want to turn this around into slope-intercept form if you were solving by graphing, because you would want it to be pretty accurate for our purposes. Well, hello. Careful what you say. You're on tape. Just saying. So your x-intercept is -5/2. Hi. which is negative 2.5. Wait, hang on. Hang on a second. And then y would equal negative 10 over 3. So if you're going to graph those points, your x-intercept is about negative 2.5. Negative 10/3 is about negative 3 1/3-ish, a little bit more than negative 3. There's your line there.
You didn't lose the paper.
Really? What? It's your y-intercept, x-intercept. Did you say there's a green thing in the corner? What are you talking about? Okay. And then you would have 6x equals negative 24, and negative 4y equals negative 24. So your x-intercept is negative 4, your y-intercept is 6. So y, you'd have to go up a little bit off the graph, which is fine, and x is negative 4, and there's your graph. This is by far the easiest way to graph intercepts. And for some reason that concept gets complicated and people don't understand it really well, but hopefully you get it better now. Julia? You wanted me to zoom in because you couldn't see, Julia? Yeah. We good? Michaela, are we good? Yeah. Awesome. All right, that's your notes for section 1 and 2. That was the first 3 pages. All right.